Welcome back for some more right triangle trigonometry. I've kind of summarized a little bit what we did in our last video with our sine, cosine, and tangent, setting up those ratios. So those three trig ratios you learned about last year, we're reviewing to this year, but there are three more trig functions, okay? And these three new trig functions are our reciprocal trig functions or trig ratios, however you want to refer to them, okay? We know that the term reciprocal, we take a fraction and we flip it. So a over b becomes b over a. So what I'm going to do to my sine ratio, instead of opposite over hypotenuse, I'm going to have hypotenuse over opposite. That's going to give me a new ratio, a new trig function. And the reciprocal of my sine is what we call cosecant. Cosecant is the reciprocal of sine, and we're going to shorten that to CSC, cosecant. Okay? And all it is the reciprocal of sine. We're going to do the same thing for cosine. We're going to take adjacent over hypotenuse, and we're going to make that hypotenuse over adjacent, and we're going to call it cosecant. Oh, wow, we just did cosecant. I mean secant. Secant is the reciprocal of cosine, and we're going to shorten that to SEC, secant. Secant is the reciprocal of cosine. We're going to do the same thing for tangent. Opposite over adjacent becomes adjacent over opposite, and the reciprocal of tangent is called cotangent. And we're going to shorten that to COT. It is not cot, it is cotangent. Okay, cool. That's all it is. It's, yes, recognizing which one goes to the original three, but all you have to do is flip your fraction. Okay, so let's look at an example here. Not drawn to scale, so don't judge me. Let's say this is 8, 15, and 17, and I'm going to call my angle here, this is alpha. It's not the most accurate or pretty alpha, but it is what it is. Okay, so I have my triangle, and now instead of just finding 3 trig ratios, I'm going to go ahead and find 6 trig ratios. So I'll start out by finding my sine of alpha. Sine of alpha is opposite over hypotenuse, so that's going to be 15 over 17. Well, now that I know sine, I can find cosecant pretty quick by flipping it. It's going to give me hypotenuse over opposite, which is 17 over 15. That's it. Okay? Cosine of alpha, that's going to be 8 over 17, which means its reciprocal secant of alpha is going to be 17 over 8. Tangent of alpha is going to give me opposite over adjacent, so that's 15 over 8. And its reciprocal is cotangent of alpha, which will be 8 over 15. Okay? Not bad. It is what it is. There we go. I'll give you one more practice problem here. You can go ahead and hit pause, try it on your own, then come back and check. So my triangle this time, I'm going to have the side lengths 14, 50, and 48. I'm going to call this angle beta and this angle theta. So I'm going to switch it up a bit. Wait before you try this one, because I'm going to give you specific things to find. I want to know the sine of beta, cosine of theta, and the tangent of beta. And then I want to know the cosecant of theta, the secant of beta, and the cotangent of theta. What's happening here is remembering your reference angle tells you which side is opposite and which side is adjacent. And a little hint here, when you're finding your trig ratios, make sure you fully simplify your ratio. you want that fraction to be fully reduced. Okay, so let's take a look. The sine of beta is going to be opposite over hypotenuse, which is 14 over 50, which will reduce to 7 over 25. Cosine of theta. Theta is here, so the adjacent side is 14. So that's going to be 14 over the hypotenuse of 50. That's going to give me 7 over 25. If we notice, the sine of beta is equal to the cosine of theta. Pretty cool. Tangent of beta. That's going to be opposite over adjacent, which is 14 over 48. So I'm going to get 7 over 24. Cosecant of theta. Theta, the opposite side is 48 and the hypotenuse is 50. So that's going to give me 50 over 48, which is 25 over 24. Secant beta, that's going to be the same thing. Adjacent is 48, hypotenuse is 50, so that's 50 over 48, 25 over 24. Notice they don't match their cosine, they're not reciprocals because the angle changed. I did that on purpose to make sure you fully recognize opposites and adjacents. Okay, last one, cotangent of theta. You're going to have adjacent over opposite. So that's going to be 14 over 48, which is 7 over 24. Okay, little tricky on that one just because I changed up the angles a little bit. Fully simplify your fractions. And then we're going to come back with another example where we're not using Pythagorean triples. What happens if our sides aren't nice numbers? Check back in and take a look.